All righty, welcome back to the 2022 Solar Decathlon Design Competition. This is the new housing division, and we are getting ready to welcome our next group. That is the University of Alaska Fairbanks, Akshevik. Right? Did I get Akshevik? Thank you. University of Alaska, if you're in the house, we are ready for you. Yeah, you got a couple minutes.
Oh, okay.
Elizabeth, I see you're there. Can you hear us loud and clear? Great.
I think we can just step up.
Yeah, and whenever y'all are getting ready to chat, maybe just step up to the microphone so she can hear you loud and clear.
All right.
I'm just gonna wait just 2 more minutes. I know this is the worst part of it, but you just gotta wait for it.
Standing here in front of everybody like this?
Yes. Did y'all do anything fun in Colorado or anything fun planned while you're out here? Solar Decathlon, that's the highlight of it?
Yeah.
Great. No, you're great.
Hey, just so you guys know, we've been watching and you guys all made it look a lot easier. Thank you. Yeah.
We'll just give it 1 more minute here. I know this is painful.
What about your energy jokes? Thank you.
Oh, one of my energy jokes.
Yeah.
Oh,
Yeah, pretty good.
sure. What is it?
What did one wind turbine say to the other wind turbine?
Yeah, you tell us. What did they say?
I'm a big fan.
Yeah.
Ah.
Yeah. Yeah. Okay.
Should we move this so it's up front?
Yeah.
Oh, yeah. Yeah. put it in front of them. Oh, better. Can Elizabeth see it?
If you bring it over a tiny bit, it'll come right into the camera. Just a tiny bit. No, no, it's
No,
all
it's
right.
not.
That's right. A little bit more, a little bit more. Maybe.
Yeah. Jump over.
You just gotta give it a little push. No, tiny bit more, almost there. There you go, Chad.
A little bit more. A little bit more. There you go. Perfect.
Yeah.
No, lift it up just a little bit. So let's like go up. No, the bottle. Oh.
There you go.
There we go.
Yay.
Blowing our screens. Okay. University of Alaska Fairbanks. Akshevik, take it away.
Hi, we are the University of Alaska. Sorry.
You guys go to the left. Yes.
Oh. Okay.
Should we do a mic check for Elizabeth really quick? A little bit more.
She'll interrupt you.
Okay.
Yeah, you guys are great.
Okay. We are the University of Alaska Fairbanks, Team Akshevik, which means blueberry and Inupiaq. We represent UAF's Sustainable Energy Program. Our design for the new housing division is the Village of Solomon VOS home.
The opportunity to design a home for the Village of Solomon was presented by Deila, who is a VOS tribal member and a consistent advocate for her tribe.
Village of Solomon is a displaced community with most tribal members residing in Nome, Alaska, which is 35 miles from our village site. Recently, the tribe set forth an affordable housing plan containing a new construction component that addresses overcrowding problems in the community and a region-wide housing shortage.
Our project site is located within the residential zoning district of the city of Nome at approximately 64 degrees north. This site is on undeveloped tundra, on sensitive permafrost, and is exposed to coastal conditions along the Bering Sea. In climate zone 8, we have accounted for 14,000 heating degree days.
Our home must last for generations, so it's designed to be resilient throughout a changing climate. Our goals are to make this home multi-generational, energy efficient, emergency secure, and replicable. These 4 goals guided us through our design process and helped us to address all contest components of this decathlon, which are interwoven throughout our design and in this presentation.
Multi-generational living is addressed with a universal building design that considers family members from birth to elder and incorporates design modifications with accessibility in mind. The VOS home is a 2-story structure with a single slope roof, which uses a hybrid construction of 4 40-foot shipping containers and traditional timber built to withstand extreme temps up to 75 miles per hour high winds, and heavy snowfall. We incorporated creative solutions made specifically for our target market and a subsistence lifestyle, such as unconditioned spaces for food storage and game processing.
Our design is tied to a culture of people, not one specific family. We are considering the comfort of the client beyond structural integrity. Customization and cultural empathy can often be neglected in traditional building design, making homes a cost detriment due to their inability to be habitable long-term. Air quality in the home is addressed with a comprehensive HVAC system that combines 2 modern mini-split heat pumps and a heat recovery ventilator, or HRV. This system warms and conditions the inside home air and ensures that fresh air is constantly being circulated back into the home. Additionally, the HRV system also removes pollutants from the air and recovers heat loss during the ventilation process. Air is expelled from the home through bathroom and kitchen vents, which also controls moisture levels in these damper areas. Integrative passive design strategies work to minimize heating needs with optimized renewable energy systems to address occupant load profiles. Innovative lighting technologies and window placement will maximize solar gains, while timers and occupancy sensors help to mimic daylight and darker winter months.
Energy costs in rural Alaska create financial hardship and design constraints. Reducing demand through efficiency measures and utilizing solar PV minimizes the operational costs. An average home in Nome can cost between $1,400 and $1,800 in electricity per year, adding heating fuel from $300, $500 per month, depending on the season. Our design projects a yearly energy cost of just $240, which eliminates the heating fuel altogether. We used Ecotrip software to model our design. Before adding renewables, our HERS rating was 17. And after adding a solar array, it dropped down to -3. Components that contribute to our better than net zero rating include extreme insulation, triple pane windows, programmable thermostats, building orientation, smart outlets, minimal plug loads, and our 15 kW solar and battery system. Modeling energy performance, we found we had to create many custom components for things like the special envelope construction, high performance windows, heat pumps, and a heat pump water heater.
Withstanding the climate crisis is imperative to encompassing a multi-generational building lifespan. Alaska's extreme weather changes are being monitored and include rising sea levels due to glacial shed, heat fluctuations, and abnormal amounts of snow. To ensure the home's longevity, the design incorporates a post and beam foundation to allow for moving of the home in the event of flooding. A tight building envelope allows for heat retention and a stable indoor temperature regardless of access to electricity or heating sources. Additional emergency conscious design considerations include north-south facing egress windows, a hidden first story safe room accessible through the master bedroom closet, and an emergency fire exit with a drop-down ladder on the 2nd floor. Backup power sources are essential due to the frequency of power outages during winter months, which is why we have a backup battery system to power essential loads, as well as a small wood stove for emergency heat.
The VOS home serves as a guiding framework for other cold climate locations. The ability to modify and customize a building design, decrease the embodied environmental impact, and move toward the future of renewable energy can be achieved in an effective manner. Engineering details of this replicable design are specific to our region. This begins with the bottom of the house elevated above a gravel pad using geotextile fabric to address area permafrost. The home will utilize an efficient heating system, high performance envelope with R61 walls, and WaterSense plumbing throughout to save water. While our target market is based on our potential client, the Village of Solomon, issues like a lack of affordable housing and overcrowding are found in many other regions. We propose a lease to own purchasing agreement for this design, modeled off of regional housing authority programs. Homes in the Bering Strait region can cost up to $500 per square foot due to materials, shipping, and labor charges. Using upcycled materials and sourcing locally helps to decrease costs, making the design more accessible to a wide range of residents at approximately $250 per square foot. While we recognize our design is still an expensive option for the average homeowner, the higher upfront cost of building an efficient home helps to reduce the overall life cycle costs and keep energy costs low. Like other remote Arctic communities throughout the world, primary transportation for supplies to Nome is via barge or air, creating an extreme carbon footprint. Shipping in bulk proves to be more cost-effective by barge, and upcycling quality shipping containers serves a dual function to enhance lifespan while mitigating new production of raw materials and greenhouse gas emissions.
The VOS home will optimize structural efficiency versus construction costs through building envelope improvements and natural resource utilization. Novel design techniques will be employed to create a highly insulated, airtight, and streamlined home environment that consumes energy sparingly. To achieve beyond net zero, a blend of location-based technologies, systems, and acknowledgement of traditional wisdom have been considered in our design. Thank you for listening to our replicable, energy efficient, emergency secure, and multi-generational VOS home design for remote cold climate, single family new housing. And, oh, sorry, just kidding. And special thanks to our industry partners, energy professionals, mentors, and our faculty advisor in the house, Mark Masteller, for your help with this challenge, and Koyana from our entire team.
Hey, thank you, team Ashravik. Do any of the judges want to kick us off with some questions?
Well, first, I love this, by the way. I loved it in the submission. I don't know who drew that, but that was super cool. Just the wall section, you had a stick frame and then you had a steel. Is the stick frame the typical way it's built in Alaska today? So you have sheathing and then you have insulation. I just was a little confused by the wall structure. So can someone sort of address that for me?
Sure. Yeah, this is pretty typical. It's a little thicker than most homes in Nome, unfortunately, but definitely getting that tight envelope. We used vertical trusses, and then we have prefabricated trusses for the flooring section and the ceiling section. And then we're planning to do the vertical truss on site and build those wall sections of the timber frame. The steel frame sections, are a little different. Those are 18-inch thick walls where they're 20-inch thick on the timber frame. But it is a pretty typical construction to have the gypsum board and then the 2x4s and then the sheathing and then insulation, a lot of blown fiberglass. And then we're getting to the outside of the barrier.
Yeah. All right. Thank you.
Yeah, tell me about your HVAC equipment. I was trying to remember and see what type of equipment are you using? Are you concerned about operations in winter months when it's very cold? We have issues with cold climate heat pumps even here in Colorado and hitting efficiencies, but also getting capacity out of them. How did you all address that?
I'll go. Our design, we did 2 mini split heat pumps. They're ductless. And the reason we did 2 is because they're a newer model that we're looking at that are rated to -15 at full efficiency and can go even lower, but they might not be quite as efficient then.
Okay.
And so those smaller ones only have 1 head. So we had to do 2 instead of being able to spread it out.
Just an extra note on that. Each of the heat pumps can function at, I think, the minimum efficiency was 12,000 BTUs. And so combined, those are about 24,000 BTUs. And our home, we have 14 degree days.
Okay.
And so optimally, we're shooting for 27,000 BTUs. So we think we can get that out of these high performance mini split heat pumps.
Fantastic.
And we didn't choose a ground source heat pump because it's an invasive procedure and because we want to be able to move the home, which is pretty common in Nome to be moving home. So
I think this is a fabulous project. I felt so bad about the social injustice that your school closed down, so you have to move to the city, and that just seems very unjust. I love the little, as I was saying, the little Arctic door where you could bring your food in and process it in a safe, clean space and have it thermally insulated on the outside. You really knocked it out of the park as far as the insulation and the HVAC and the solar and, having the backup. My great concern is kind of like what Nathan said is, the maintenance in the winter time, and you put the little snow fence out front so that it protected the home. So you really looked at a lot of wonderful details, and this is a really good project.
thank you.
Elizabeth, any questions or comments for the team?
Yeah, I think likewise, I love what you've done here. I feel like you have a really strong sense of place that I can see reflected in your design. I think typically I'm a little skeptical of shipping containers being really cost effective. And I think here you've demonstrated why. I mean, it's a dual purpose, why you're using the shipping container, which I love. Can you talk a little bit about you have 2 shipping containers side by side in the living and dining space. And so that's a 40-foot long kind of clear span. Are you just not having roofs in that section? Like, how are you supporting the roof of the shipping containers in that large area?
Thank you. Yeah, do you want to back up to our floor plan? So yeah, we have the 2 40-foot shipping containers on the lower floor. And they're high cubes, so they're a little taller than standard 8-foot shipping containers. And although in that rendering, the one on the next slide, it kind of shows them set next together, but actually we're going to be cutting out the center sections there and welding them together. And then the vertical trusses on the outside of the home will support the entire structure as well, in addition to the steel, which is pretty supportive of the home.
So just welding them together, you don't need additional steel reinforcement?
That's a great question.
I'm curious. I don't have an answer.
I don't believe we will. I think maybe we might have to add a little above to carry some load, but that's a question for a welder.
Yeah, I think one thing to consider is you could just, I mean, instead of carrying the load all the way across that 40-foot length, you could turn it 90 degrees perpendicular and carry it across the internal insulation wall, so that you didn't have that large span. Like, I know that can get really expensive. I think there's different ways of dealing with it in your configuration. Also because you have a roof above it, it's not serving as a roof. So you could just use it as the walls and get rid of the roof. So I think you have a lot of flexibility and things to consider there.
Thank you. Thank you.
So I'm curious, how do you integrate a window in the wall?
With a really, really thick windowsill.
Okay.
So yeah, our windows are on the outside of the home, so the windowsills are really thick, but they've tested putting them a little back before, and it's bad because it just fills up with snow. And so yeah, that'll be added.
Okay, so on the exterior, it's of the exterior.
Yeah,
Okay.
And I also want to just note, since you commented about the windowsills, we made them deep because of storage, like people can and pickle, and that's additional like cold storage just
That's
for the
good.
winter.
How would your lease to own model work?
That is where we had partnered with the Bering Strait Regional Housing Authority. She has, actually, the Village of Solomon does have a working affordable housing program, and a lot of our documents have been templated and modified from her documents, and we've had several consultations and meetings, making sure that we implement something that can work, but also not specific just to the limitations of the residents in Nome, because the Village of Solomon does have tribal members outside of Nome too. So we want it to be able to serve region-wide throughout Alaska or the lower 48 also. So we had to custom some of those policies and documents. And that seems to work for them.
In the submission, you said you use adhesives instead of nails. Can you just talk through that a little bit?
We have hired a project manager through Arcadis because the undeveloped tundra on our project site does need construction of a gravel pad. And so that was from meetings with him, Mike Cruz, on how we can minimize the thermal bridge using the screws and nails and such. So adhesives, making sure that we find the correct one, but adhesives is the route that we would like to take.
I mean, our cars are put together with adhesives, I'm just saying.
Right.
So we think that we can find a way to do it in construction, but we haven't yet. So I was just curious.
I think I have one question and one comment. Just curious, so definitely an aesthetic and elevation that is pretty unfamiliar to me is how does that exterior elevation compare to the existing homes in Nome? Is it gonna fit in, stand out? What's it gonna look like?
We both lived there for a while, so go
Yeah.
ahead.
Yeah, this is, it's going to be a little higher than some homes, but newer homes that are being built in Nome are pretty much a 2-story construction. And a lot of people use the second story as the warmer areas for a lot of bedrooms. But this is a pretty standard for Nome. Most homes are going to be elevated off the gravel pads at least 2 feet, sometimes 3 or 4 feet, depending what kind of foundation they're using.
Just an additional comment. So we did look at the different foundations. There are these metal triadetic foundations, and some of that was aesthetically not pleasing, and it's a little bit higher than the traditional post and beam. And so the other thing we were trying to consider were job creation in the area, and using a traditional post and beam foundation fits in with just the current culture in the community.
And then the one comment, just reviewing your energy model documents. I see that you've got the heat pumps modeled with their COP coefficient of performance rather than HSPF. Just for a heads up, not quite standard practice. The only time we really use COP is when we have ground source and we know that we're gonna have a pretty steady state COP. Whereas with air source, that COP is gonna vary so much over the season that you kind of have to use the HSPF. So also just knowing ecotrope, it's probably gonna cost you about 10 to 15 hertz points if you changed it to that. It's a weird software, but that's the reality.
Thank you.
Yeah. Yeah.
And how did you get these Lego solar panels?
They're actually actual solar panels made for little toys, so they're hot glued on. I was gonna splurge for the Lego solar panels, but we didn't, so they're hot glued.
Like there was some solder on there.
Yeah.
But they don't actually power the lights.
No, I didn't get that.
We've still got 5 more minutes for questions for judges or jurors. Elizabeth online as well.
You had some comments around wind energy. How would that have changed? If that's available, how is it going to change your design?
Yeah, that's something we would love to push on the local utility to use their curtailed wind, because right now they just really can't. So they have these big generators that are oversized and they have to run them at a certain efficiency because of air quality requirements. So they can't use all the wind. So right now it's just getting curtailed, wasted. So if we were able to tap into that, like they've done in other parts of Alaska, it'd be a great way to add like thermal stoves or heat local buildings, so something we'd like to look at.
Have you looked at any rammed earth solutions for walls up there, so you don't have to ship them in? You can use more local material.
We did it specifically for our design. That's something I think they're studying at CCHRC though, in Fairbanks, but.
Yeah, and if you ever go to Nome, it's so isolated, dog sled and cruise ship, but cruise ship is usually vacation or airfare, that's how you get there. And so shipping containers are littered all over the town. And one thing that we would really love to see is having a good use for them, especially with the housing shortage. So that's why we specifically chose the shipping containers.
So do they come one way then, the containers?
Seems that way.
Okay. All right.
Yeah,
Just
a
curious.
lot of them are
Yeah.
only one-way shipped and then left.
So that makes good sense. That's just a really interesting project with considerations that I would never have thought you would need to, because I don't live in Alaska. And I don't hunt.
One thing that something that we had to consider in our design was, I remember going to visit my mom's house, and she has a fairly newly constructed home, and having to use a blow dryer because of the orientation of the front door and entryway, because the wind is blowing and it's so cold that it's iced. And so you have to melt the ice in order to shut the door. And that's for the front entrance. So having lived in this kind of a climate and having experience with the design considerations and how we can best have the most efficient occupant experience for the people of the that are going to reside there, weighed heavily on all of our design constraints and design goals, design objectives.
That's great.
Really, I think the biggest thing with the multi-generational aspect of it is we want the family to want to stay. And if the house is not customized to that area, the traditions, people leave. So it's more multi-generational so that it lasts the generations of the family and also considers traditions of the family.
The people.
I loved your part on focus on cultural empathy. That was lovely.
That was Meg.
We got just under a minute. Any last comments or thoughts for the group?
Yeah, I know that daylight is so important to people too. Can you talk about how you thought about the daylight in this space, especially in the different seasons?
Yeah, they call it the land of the midnight sun. So when I go there with I'm a mom, I have a 7-year-old, so we go every summer, and it's midnight, literally midnight. And I'm closing the blinds and he says, no, it's morning time. Like, you literally have to have decent curtains and shades during the summer months because those sun will not go down. And then opposite almost in the winter. If you want to speak to any of that.
Yeah, like we have very minimal window placement, which you'll notice, but it's all focusing towards the south, which is facing the sea, which is a beautiful view, but also the most sun, and that's where all our solar panels face. And then this north facing side is looking at the mountains, which is also beautiful. We've got hardly anything over on the west side, just a kitchen window, but not much daylight there. And then on this side, on the east side, we've got a couple windows, but we're keeping our windows as small as possible. If we could remove them all, we'd have a better energy score, but we need daylight in.
Well, that about wraps it up. Let's have a round of applause for Team Australia.
Wanted to say the artist is, I believe, Yvette Reyes that drew our team picture.
Oh, it's just fun.
Thank
Yeah,
you.
super
We
fun.
hadn't
Yeah.
come together before this, so we had to get.
We all
an
did it
artist.
Oh,
remotely.
really?
Yeah.
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 What?
Yeah, and
Yeah.
she is an Indigenous artist, and that was very important for us to support an Indigenous artist through this as well.
That's super cool.
Our advisor hand.
Thank you, Team Australia. Next up, I believe we have Ferris State University. Are y'all here? Great. Come on up.
That was interesting.
Say, I-
Thank
Yeah.
you.
No, it was on I was on there when you moved it over from there. Yeah.
Howdy, Ferris State. We gotta wait 5 minutes to allow y'all to start. I know, it's gonna drive you crazy. Do some jumping jacks. Or tell
Do
us.
you- yeah. Do you have an energy related joke? That's what we need.
Unfortunately not.
You have a water fowl joke.
No, I don't.
Why did the solar panel forget to take out the trash?
Why?
Because he has no energy at night. Elizabeth liked it. Yeah, there we go.
That was great. Yeah, I
Fair
love
for
it. I feel that one very deeply.
Y'all have any fun plans while you're out in Colorado?
I think we're gonna go downtown Golden.
Downtown Golden.
Yep.
Go to Woody's. Hit
My
the-
alma mater.
Yeah, hit the pizza buffet at Woody's. It's really good.
Write that down.
Yeah.
Do not go to Coors.
Try to make it up to Red Rocks. That's what I've
Yeah.
been encouraging people. It's definitely worth seeing if you can get up there. But Woody's, yes.
Be
Alright,
prepared
$1.21,
to-
they have really good Bloody Marys.
Gotta come back.
Next year, there you go. Well,
No.
Just the three of us.
Yeah, why don't y'all introduce yourselves and your major? We'll make sure that the virtual jury can hear you.
Okay, so can we like adjust it slightly maybe? Oh, I think we're all pretty short. Well, okay, Corey is the odd one out here. I'm Haley Wilfong. I am a junior at Ferris State University in the Architecture and Sustainability program.
I'm Nathan Seaman. I am also a junior in the Architecture and Sustainability Program at Ferris.
I'm Natalie Dunveston. I'm also in the architecture program at Ferris State.
I'll finish this off and say I'm Corey Hoffman in the Architecture and Sustainability Program at Ferris State.
Elizabeth.
Thanks, that was super clear.
Great. All right. Just a couple minutes and we'll keep y'all up. But your support group here, huh?
Yeah.
That always helps. Seeing some familiar faces. There's an ice cream spot in downtown Golden that's really good too. Golden Sweets. They have all sorts of stuff.
If only we knew that yesterday when it was 80 degrees out. We were not ready.
Give it just one more minute and we'll keep y'all up. Okay. We are ready to begin. With no further ado, this is Ferris State University. Live still? Am I saying that
Yes.
correctly?
Yeah.
Okay, take it away, Live still.
Live still is more than the Danish word for lifestyle. It is a vision. Suburban living in the United States is not known for its sustainable practices, but with our design, we plan to change that. This is Studio 105, and this is Live Still, tradition meets sustainability. I'm Nathan.
Haley.
I'm Corey.
And I'm Natalie.
When designing the Live Still house, we aim to not only meet the requirements for the Solar Decathlon competition, but also to integrate Live Still into, or HIGA, into the daily lifestyle of the occupants.
Our site 9402 Cottage Park Drive is located south of Greenville, Michigan on the perimeter of Burgess Lake. The site is heavily wooded with a mild slope to the south facing the lakefront. The site is suburban in relation to Greenville, so a sustainable source of transportation must be integrated.
Montcalm County is defined by the IECC 2015 Climate Zone 5 in the subtype B. Greenville, Michigan is a primarily cold climate similar to that of Denmark, which was the inspiration for our concept HIGA.
Hygge is the Danish concept that refers to finding comfort in the simple things of life, such as a cozy atmosphere of spending time with loved ones. Due to the nature of our project and the Danish heritage that is found within Greenville, Michigan, our project encapsulates the concept of Hygge. The Live Still house encapsulates surroundings, suburbia, and society, and the existing site encourages outdoor activity and a respect for nature. We chose a suburban site for a new housing development with hopes of showing how the boundaries of sustainable design can be stretched and inspire a shift in residential design thinking. The Live Still home responds to social sustainability through the incorporation of Danish culture.
When designing the building systems and thermal envelope for the Live Still house, we made sure to accommodate the context that the building would be placed within, as well as our goals for the experiences we wanted to bring to life within the design. Our target occupants are the average upper middle class family found in Greenville with 2 parents and 3 children, and an average income of approximately $85,000 per year. After a down payment of $50,000, a 30-year mortgage will be established at 5.35% interest, which will bring the total mortgage to $449,437. The monthly house payments, which will account for property tax and home insurance, will come out to $1,930.66, which is within reasonable amounts for our target occupants and will be further offset by the reduction of an elimination of energy and utility bills. The cold winds and heavy precipitation in Michigan require that the exterior materials and interior materials are designed to be durable and long lasting. We determined that the live still house would be designed to last for 100 years. And in doing this, we had to ensure that the materials were A, environmentally friendly with a low environmental impact, and B, durable and resilient.
Our team chose materials that were produced sustainably with the location and material source in mind and distribution centers. The location of the home site and the city of Greenville offer a wide variety of choices in terms of materials and resources. The use of local and sustainable materials will be used to introduce the design to the community through the use of local labor. In addition to embodied energy, several other measures of environmental impacts must be measured, including global warming potential, acidification, eutrophication, and smog formation.
An effective envelope helps lighten the loads of the HVAC system, and the building form allows the HVAC and ductwork systems to function properly throughout the home. The slope and orientation of the site have an impact on building performance in terms of passive strategies. Glazing allows for direct solar heat gain to warm the spaces in the cool winter months, while triple glazing and roof overhangs help prevent excessive heat gain and heat loss. The roof orientation allows for the placement of 4D solar panels, and a rainwater collection system purifies and circulates water back into the home's plumbing system.
The Live Steel home was designed for a single-family household to bring them closer together. The first level is an open concept design to promote conversation within the family and their guests. Sometimes comfort comes from being alone though, so there's areas throughout the home to provide just that to the individual. A smart home system is embedded into the infrastructure. This design ensures that every other system works efficiently, saves money, and provides safety to the family. All appliances are going to be electronic, stainless steel, have an Energy Star rating, and manufactured by Samsung for optimal connectivity throughout the home.
The HVAC system, a ground source heat pump with energy recovery ventilator, was selected with occupants' comfort and system efficiency in mind. This utilizes a vertical closed loop system in order to maintain the existing trees on the site. Mechanical selections and load calculations were performed by our HVAC student partner.
Using passive design strategies as well as efficient selections for the thermal envelope as well as appliances and internal fixtures allowed us to create a house that is more efficient than the average residential project in the United States, achieving a HERS score of 38 without renewable energy. With help from our design partners, Michigan Solar Solutions, we were able to develop a solar array capable of supporting the energy needs of the house, as well as providing energy to power an electric vehicle. With the incorporation of renewable energy into our project, we were able to achieve a HERS rating of -9. By calculating the estimated cost of electricity for the area based on the needs of our project, we determined that the occupants will be saving $389.91 per month, which will account for the cost of purchase and installation of the solar grid in just under 3 years.
The Live Steel home utilizes the slope and an open concept floor plan to create a dynamic and functional design. The 3D form was topped with a large gable roof that resembles those of Danish architecture. This roof structure was subtracted from to create the 2 large shed roofs with a green roof in between. We included outdoor experiences to encourage an interaction with the site, and the exterior colors allowed the building to become a backdrop for the site and the blue of the lake. The Scandinavian color palette creates a contemporary and soft and cozy atmosphere within the home, and the wood and warm neutrals blend with the site and the incorporated greenery. In learning from Higa, we can create a future where sustainable living is not only ideal, but standard practice.
That was perfect.
Cut you off
Yeah,
there.
that was perfect.
Great. Let's have a round of applause for our team. And we have 15 minutes for questions from our jurors starting now.
I can dive in first. Was curious, so your overall form, just curious about your mechanical room. Is there gonna be enough head height to actually put equipment and a tank and everything that you need to in that space?
Yep, so the roof does slope down to the floor there, but there is enough space up against the office there,
Okay.
and that wall is insulated well enough to hold the mechanical space and the systems that will reside there.
The other question I had, and I was curious, if you go back one slide. Yeah, this lower right, what type of doors are those? They sliders or
Yeah,
they?
they're sliding
Okay.
patio doors.
Okay. Yeah, they, the grid pattern on them made them look like they could possibly be garage doors. And that's, while it is modern and I'm seeing it a lot in homes, they're very uncomfortable, they're very difficult to air seal, and they will kill energy consumption in a home. So I was just curious. Thank you.
So the doors that we selected there are from Endure, they're patio doors, and they are fiberglass insulated glass doors.
So I love the porch, by the way. I'm a big porch person, so I'm glad you added that. But I did have you, you had a statement in the submission that said wrapped to correct tightness to achieve ACH3. Do you have any detail around that you could share with me?
So we don't have any specific details, but we designed the building and the envelope in order to meet Michigan code requirements, which are an ACH of 3.
Okay.
Yeah.
Yeah, just in general, it's hard. It's not an necessarily easy thing to do. Like, so the integration of the components together is so critical to make sure that you're not getting air leakage. So it's good to see the details around how you're going to achieve the air tightness, because you can do air tightness sealing from the exterior and the interior, or some blend of both to achieve that. Trust me, builders are trying to do it all over the country, and it's not as easy as it seems.
So I own a geothermal solar powered house with a HERS rating of -9. So I really like this project. It reminds me of home. But I'm also a developer and a real estate broker, and something's wrong with your calculator. For a $500,000 house, I'm getting like a payment of $2,500 a month instead of $1,200 a month. So at 4% interest, and you're using 5 3/4. So you might check that out. And then the drywall cost was $165,000 for this house. Did that include more than just drywall?
I believe that the cost of labor was split among all of the categories and materials selected for like application and shipping.
So it wasn't all put into drywall.
Yeah,
Do you know what the utility rates are in your, to get a $389 a month payback on your solar is really phenomenal. Do you have really high rates in Michigan?
I'm so sorry. The $389 is the saved electricity used in the home.
Right. So what do you pay for electricity though?
It would cover lighting, fixtures, appliances, and heating and cooling.
But what's your cost of electricity?
The actual utility cost off the top of my head, I wouldn't know for Greenville, Michigan, but I believe it was in our supplemental materials.
Okay.
Elizabeth, any questions for our team?
Yeah, so I really love the concept of Huga and how simplicity is so valued. So quality can come through even though you have a really simple form and lifestyle. When I look at the design of your building, I see it's like a very complex shape and multiple foundation levels and things like that. Which, like, when we're doing really cost-effective net zero housing is, we try to simplify the form as much as possible. But I see that you're also trying to do some other things with having that complicated form. So can you just talk a little bit about how you balance those two things, the complexity of the form and the cost, and then what you feel like you're getting out of it by having the shape that you ended up with?
Yeah, so our form kind of comes from the slope of the site. We wanted to create a dynamic building. And so it does have that walkout slider that opens up into the patio. And that's kind of the outdoor experiences we were talking about, what we're getting out of those 3 levels. And while it does make it a little more complicated in both construction and cost effectiveness, we are offsetting that with the use of solar panels and recyclable materials throughout the design. If that answers your question.
Thank you.
I have a question about your wall assembly. So wanted to know, did you look at any other assemblies, look at any other options? What was your thoughts in coming to this 2x8 wall?
Well, we wanted to do typical wood frame construction in the home, but in order to achieve the R ratings we wanted and were shooting for, we knew that we were going to need the space for our cellulose insulation, which is a little thicker than regular, but it is more sustainable, which is where that trade-off came into play. So we needed to make the walls a little thicker than typical residential exterior walls.
Okay.
And just to add to that, we did want to stick with the typical wood frame construction because that also bounces back to Danish architecture and their typical wood frame houses as well.
Yeah, my only comment on 2x8 is you have to change the design details to do it, like how your windows, your fasteners, how you fasten cladding. It's not a very typical construction methodology. 2x6 is probably a little more standard for your market.
And then the other, just looking at the wall assembly and looking at what you've got going on, I think you've got I would just say in your construction documentation, work on maybe some standardized language, because I'm seeing in some sections it's 7.5 inches loose fill insulation, and other sections 7.5 inches spray foam
I saw the same
or
thing.
spray insulation. So just coming to a common language and using that consistently would help. And then being sure that you're calling out the material type in that. Because when I see spray insulation, my first thought, and I'm glad I looked a little deeper, was wow, 7.5 inches of spray foam insulation. That is a lot of foam and it's very expensive and has a huge carbon impact. So I'm just a word of advice. And then talk to me about your slab. It seems like you have this interesting, insulation below, insulation above your concrete slab. Can you talk about your reasoning for that, or what the goals were, or maybe tell me I'm misinterpreting your details. That's entirely acceptable as well.
Well, when it came to our foundation, we knew that we wanted to reach a certain R value, and we thought that by putting some insulation below and some above, rigid below and I believe rigid as well above, we were able to space that out a little more, so we didn't have such a raised carpet level or flooring. So that played into that element, but that's correct, there is insulation above and below.
Said interior walls are fitted with acoustic panels. So can you give me a little more information around that?
Yeah.
Yeah, I think managing sounds important. I'm just curious a little bit more about that detail.
Of course. So we obviously in a home, as we mentioned in the Akron experience, it's important for there to be spaces that are full of conversation and prospect, but also lots of refuge, because in this new world, people have found solace in being able to be alone. The actual design of the interior walls, I believe we use like some acoustic panel that I cannot think of the name of now, but it's inside the wall assembly.
Okay.
And with your geothermal system, are you using a superheater or are you using a standalone tank?
The geothermal heat pump that we selected actually has a a D superheater in like inside of the heat pump. And so that will, the heat pump itself will manage all of that, and then the energy recovery ventilator helps pull that heat back in.
Is geothermal very common in this area?
Yeah, geothermal ground source heat pumps are very common in Michigan and in the Greenville area.
Specifically.
Still got about 5 minutes. You can call it early if there's no more
Well,
questions.
I do have just one more question, just looking at the design. I'd love to hear your thoughts on what's the value of the green roof? You know, what was your goals with that? How does it fit into the design? That is a big cost. So making sure that if it's there, it's important, it's focused on. What were your thoughts on it?
For the green roof, we really wanted the occupant experience to kind of tie into the nature. With Burgess Lake just being right there, we wanted another space for them to kind of stay to themselves while looking over that lake.
Just to add to that, part of Danish life and culture, and one of the elements of Higa is that connection to nature. So throughout our design, we have outdoor experiences with nature. There's plants placed interiorly, and then also the green roof is just one more way that we've allowed nature to come into our design.
Are my notes correct that it's 3,600 square feet house? Is
Yes,
that
that is
common,
correct.
or is there a more efficient way of use of space? Or
So that is very common for the specific area, the Burgess Lake Preserve. I think that if we did have to do this project again, we would try to get that footprint smaller and save in the cost area. But the typical, 2-parent, 3-children household is the normal for the specific area that we're located.
I think the project said that you use plywood and not OSB. Is there a reason you chose one over the other?
I think that OSB and plywood are both used at different points in the project. I think plywood was mostly internal.
Okay.
And OSB external.
I'm just looking at my notes.
Still got another minute. Are there any comments from the jurors or Elizabeth online?
I love your concept of Higgy and, bringing humanity to architecture. And so thanks for doing that.
Thank you. Thank you so much. Yeah, it's pretty.
Great.
No other
I think
questions?
That's all.
Yeah.
We'll have a round of applause for. Okay, I believe now we have a break scheduled. Up until we'll meet back here at 35 minutes after the hour
All right.
for our University of Victoria, British Columbia team.
The next two are online.
No, they're on site.
Okay.
Yeah.
Wow, great.
And then we got 2 online after that.
I think it's Australia and yeah.
I am. I just don't want people seeing me eat.
Oh,
on
no,
the
you're
dark
fine.
screen.
We're gonna go ahead and get started here, all
Great.
right? Cool. Thank you all for joining. Welcome back. This is Solar Decathlon, New Housing 2022 Design Competition, and this is our team from the University of Victoria, British Columbia, the Solar CCAN Tiny Home. Take it away.
Hello, we are from the University of Victoria in Victoria, BC, Canada, and this is our Solar CCAN Tiny Home. We'd like to first start with thanking our sponsors, the Pacific Institute for Climate Solutions, Island Technical Installations, UVic Student Society, UVic Integrated Energy Systems. Without them, we wouldn't be here today. We're looking forward to taking this golden opportunity to share our design with you today. Firstly, I'd like to introduce our teammates with Satria, Connor, Fumika, Jasmine, and myself, Adam, and Evan, who can't be with us today, but is on Zoom. The site for our proposed project is in Victoria, BC, our hometown, with a 4C climate zone. This new building is 320 square feet in area and targeted occupancy of 2 people. Constructed with various repurposed and sustainable materials, this boasts a shipping container integrated as the structural body of the unit.
The overarching goals of the project is to have an affordable, highly efficient home, minimal impact to the environment, provide excellent quality of life for occupants, and influence a broader societal change. However, there were several challenges that were accounted for, and that's the constraint space of the CCAN structure, highly conductive steel, moisture problems arising during the cold weather, and minimal structural penetration for air tightness. Slide, please. This is a rendering of our CCAN. As you can see on the roof, there's our solar panel array and overhangs above the windows that are made from reused window cutouts.
So this is a floor plan of our CCAN. So a few architectural details to note. On the left, we have a localized plumbing system to help reduce the length of the pipes to minimize heat loss. We also have the washer and dryer unit located in the bathroom, and all of that is at one end of the unit to help create some separation within the unit while keeping an open concept design to help implement our passive house heating design principles. And then we have south-facing fenestration with overhangs to help optimize seasonal exposure to sunlight. The roof pitch was designed to be 36 degrees, which is the optimum angle for PV generation in Victoria at the site location. And we included a simple rainwater collection system to provide purified drinking water with a storage tank located in the roof.
And this slide shows the exterior wall assembly. All layers are secured using adhesive. And in order to create a flat surface on the inside of the container, corrugated mycelium panels were affixed to the inside of the metal. And then attached to these, we have vacuum insulated panels, which enable us to achieve a high R value with minimal wall thickness. And then we included moisture barriers on both sides of the insulation layer. And then finally had a drywall finish on the interior. And this slide shows the structural design considerations. So the roof assembly was designed to be prefabricated, consists of PV panels on metal roofing material with wooden rafter supports. And the foundation is designed for the container to be secured to the ground with isolated footings at all corners, as well as the midpoints of the container.
Now, from the electrical perspective, we focused on designs with measurable performance. First of all, the structure allowed enough room to install a 9-kilowatt solar power system. Then for lighting, we calculated a very low power consumption using LED bulbs. And finally, for our HVAC system, we selected a heat pump and a heat recovery ventilator for their high efficiency. Next slide. Now here you are looking at the plumbing layout. The piping design would minimize maintenance needs and heat loss. And along the pipes, we decided to install tankless electric water heaters due to their efficiency and the space constraints.
All figures shown on this cost slide are in Canadian dollars. The total construction cost was estimated to be approximately $80,000. Through the net metering program for the solar panels, the owner will have $1,200 of revenue in the first year from the PV generation. And with a slight degradation of the production over time, this results in $30,000 of revenue over 30 years. And the small size and minimal equipment in the unit results in a very low maintenance cost, which makes our design much more affordable than a typical home, as you can see from the figures here. As I mentioned earlier, our project is built out of a repurposed shipping container. The cordon steel material withstands extreme weather and is incredibly durable. To ensure there's optimal temperature within the unit at all times, a heat pump is paired with a passive heating design. To improve resilience, a rainwater collection system was added and is purified on site.
A life cycle assessment was done using Tally. The most important point we can see here is the global warming potential of 5,085 kilograms of CO2 equivalent. The embodied carbon was around 170 kilograms of CO2 equivalent per meter squared, which 24 kilograms of CO2 equivalent per meter squared is less than the average passive house Part 9 building. Most of our carbon emissions came from production and end of life cycle. The transportation was kept at a minimum by using locally sourced material, and the green bar there indicates that 10% of our building can be reused and recycled.
Now I discuss how we use simple architectural designs to increase our energy performance. As you can see, we added windows on the south side of the building for daytime lighting. And for the material, we used triple pane glass filled with argon for increased insulation. On top of that, we added overhangs sized to optimize solar heat gain during winter months and shading during summer months.
These are a few renderings of the interior of our design. So this shows the kitchen and living area. In the corner at the back there, there's a projector with a screen that doubles as a blind to help to have like a viewing potential without needing like a TV. And then in the bedroom, there's storage underneath to help make use of the space as much as possible. And then this is looking from the bedroom down.
So for comfort and environmental quality, we used low odor adhesive that's safe for indoor use for the walls. And then we ensured indoor air quality and particulate control with a comprehensive ventilation system in the unit. We also provided the occupant with a robust temperature control system, as well as a full suite of home amenities.
For the energy analysis, the CCAN's grid-tied PV produced 13,000 kilowatt hours annually, which is 7 times the consumption. The chart is broken down based on load type, and the hot water was the main contributor for the electric consumption. An important thing to note is the mechanical energy use intensity, which includes all the loads except for the lighting and miscellaneous loads, which was found to be 46.2 kilowatt hours per meter squared. This meets passive house levels of performance by the 2018 BC Building Code. Thank you very much for your attention and welcome you all your questions.
My question is, are you a power producer first and a home second, or a home first and a power producer second?
For sure, for sure. Of course. So when we were starting out with our design, a really big concern was that we weren't going to be able to have enough insulation to have sort of like a low heating need. And so we made it like super energy efficient. And then we kind of ended up being like, maybe we didn't need to make it like that energy efficient, you know what I mean? Or like we could have had less solar panels. So we kind of didn't get those numbers until like the very end. And then we're like, wow, that's like probably like way more than we need. But I mean, what's wrong with generating more power, I guess, right? Yeah. It definitely is a lot of more power than we use, up to 7 times. But the planning with that and the design considerations were geared towards generation of funding from the net metering program within our hydro system. So each kilowatt hour would be in excess over a year period is sold back to the local utility grid at, in ours, it's 11 cents per kilowatt hour. So over a year is roughly around 1,000, depending on the data creation of the panels, as Connor mentioned. But the nice thing is it definitely subsidizes the initial costs of the unit, and definitely gives the occupant experience freedom of energy use, because they know they're not going to be paying for any of it, so just eating into their profits in a yearly basis. So yeah,
I would just caution you. In Fort Collins, we had the same thing where they would bought it back at full retail, and then they went to time of use rates, and so the rates dropped a lot.
Yeah.
And like in Denver area, Excel now buys it back at wholesale instead of retail. So it went from, 8 cents down to 2 cents a kilowatt hour. And so the payback is
For sure.
doesn't happen.
For sure.
So-
Yeah, no, it's a. Yeah, just.
We didn't think it would either. In 5
Yeah.
years, the
No.
whole energy policy changed very quickly.
Yeah, that is the one thing which is nice about BC Hydro. So if you sign up for the net metering program, you are locked in at a certain energy price for that period of time, and it's
For
kind of
30 years?
yes, or for it's basically the life cycle analysis of the project, and they'll determine that. Yeah, for ours it's 30 years. It's usually 25 to 30 years, and they'll lock it in for that period. It's more of an incentive to get people to generate power using solar panel or even a hybrid system, for instance. So it's a good for getting people in, and hopefully more and more people buy into this system. So yeah. Anyways, hopefully I answered your question.
Yeah.
But yeah.
Do you want to go next or do you want me to?
Let's talk about your wall system.
Sure.
Yes.
Yeah, that's intriguing. So I'm curious, the choice to use vacuum panels.
You took my question.
Yeah, sorry. Like what led that? Have you been able to find a consistent source for those? At least around in the US, they're still very much in a research phase, and we really only see those type of product used in very specialized locations. And so I'd love to hear your thoughts and justifications for using such a specialized product.
Yeah, I mean, it's absolutely a fair point. Like, it's more of a concept, I guess, at this point. Like, it may not be something that's easy to source for sure. I think we're aware of that. I think it was mainly like we were going for very high insulation, and the problem is like if you make the wall like 4 inches or more, there's like hardly any space left, right? Because you're losing that on each side. So it was kind of like, what can we do? And we were looking into options for that, and that was kind of what we found. It was actually kind of funny. We're doing research, we found something on vacuum insulated panels. It was mentioning what they're used for, and it had like a few things it's listed for. And the last one was insulated shipping containers as like one of the uses. So we thought that was pretty funny. Yeah, I mean, there's definitely some issues around that if you were going to actually go out and build this concept, like sourcing those could potentially be a challenge. And they're also extremely expensive per square foot. So we tried to incorporate that in our costing, but the cost that we had was about, I think, $50 to $60 per square foot. And I could definitely see it being more than that potentially. But yeah, that's definitely a fair question.
Can I follow up?
Go for it.
Yeah. So I totally appreciate, because you get more R value per inch in a vacuum insulated panel. His point is they are expensive. Another thing too is you can't penetrate them. So you can't put any.
That was why we use the adhesive. So it's like glued so that there's no penetration.
That's great, but a homeowner is going to come back and want to put up a picture. So one of the things to consider is putting the insulation on the outside. So
yeah, well, the reason we didn't do that is because then you're sort of sacrificing the durability that's inherent with the container, and then you have to weatherproof the entire outside. And so we looked into that, but we didn't really want to go that route sort of for those reasons.
yeah, good reasons. But to build it, you may have to.
Yeah.
It's just it's an
Well,
option.
there
for
is
sure.
also drywall, so that they
Yeah.
could attach things to the drywall.
You're gonna go right through it. I
Yeah.
promise.
Yeah.
I promise. You're gonna have to have a manual that tells people, don't put any holes in there. Yeah.
Yeah, I think especially because it's just, most of your walls are external, right? You don't have internal walls that are available to hang stuff on really. Except maybe the
Just a
bathroom wall.
consideration. Yeah.
Yeah, I think the other really cool thing you have in your wall is the mycelium panel, the mycelium in there. And I don't know, I'd say just go with that. Like, that's such a cool material. It grows. It's like, it's also very innovative, and you could puncture it and it'll be fine. It doesn't have the R value per inch that the vacuum seal paneling does, but that's something that got me excited. I could just see this shipping container being like in a mycelium factory, right? You spray it in, you grow it in that specialized environment and ship it off. Like I think there's some really cool potential there. One thing to think about is I think if you did a therm model and like looked at where the heat loss was happening, there's probably not a lot of benefit to having anything inside like the little bump outs, because you're going to lose heat from the where it bumps in, right? Does that make sense? I wish I could like draw this.
You mean the corrugation, like of
The
container?
corrugation.
Yeah.
Yeah. So I think you'd be fine, like just having, like, I don't think you're gaining a lot for the cost for putting insulation in there. But you could, if you were like spraying on the mycelium and you let it grow, and then it was just kind of like this curvy interior wall surface that you drywall in front of. So
I really like that idea. And I think that, you know, the insulation design was something we did earlier on. And then now that we've sort of had our whole energy analysis results that we've gotten, which is very near to the end of the project, we could rethink the insulation concept and maybe not go for such high, what's the word I'm looking for? Yeah, like R value or air tightness, and kind of like, yeah, like you're saying, bump that down. Like I think that could definitely be
you're doing good.
A small change. Yeah.
I'm really big on eating your vegetables first, doing the insulation and the air sealing. So don't back off on that part. Why 2 HRVs and 2 hot water heaters for 320 square feet?
So for the HRVs, we decided they were, I think, they were 2 like ductless HRVs. They were quite small. And so we put one in the bedroom and then one like in the living area, just to kind of have ventilation in. Yeah, to have the required CFM for the space, because they were quite small.
Okay, and how about the hot water?
That one. So we were looking at different options. So first of all, we only have electricity for utility, and also for storage, we are very limited to space. And so we decided to use point of use water heaters, because the water comes on demand, and the use expected from this unit, it's only 1 bathroom and no dishwasher or anything. So there's a dishwasher, sorry. So not very much use in terms of hot water. And yeah, we decided it was the efficient way for this design.
I think the idea of having 2 was one for like the bathroom and one for the kitchen. But I think we probably could have just used one as well. Would have been fine. Yeah, just talking about that just for a brief second. Yeah, so the one for the washroom would be like the washer that's integrated into the washer, the washing dry machine, which is for the washer. And the one would be for the shower, and then the other sink, and then the bathroom sink. So we calculated the flow rate and what's needed for the hot water and which temperature that they need to be at. I think it was 49 degrees Celsius at max. And we came with these 2 hot water heaters as far as the spec. But could we be a little bit more lenient and a little bit more conservative on that? Most likely, for sure. Yeah. So I just want to talk about
that. I'm curious, what led your decision to use eQuest for your energy modeling?
Well, we were gonna use one-click LCA, one's Open Studio, sorry.
Yeah.
And we really, it was kind of hard for us to like go through it, and yeah, we were getting a lot of errors, and we ended up talking to one of my HVAC profs, and she recommended to use eQuest, and it was like user friendly going through. It was like very structured, and you just needed to go through like all the steps that they have, and that's why we use it.
Okay, yeah, no, I'm just curious because so eQuest, Open Studio, great platforms, really powerful, but typically only used in commercial settings. So you could have looked at, maybe a more residential model or modeling platform that might have been a little bit easier, and could have maybe led to some, more upfront iterative modeling as you're looking at different things. So yeah, no, just curious about that. And I think the one question I'm just kind of looking at your layout and your floor plan, Do you have any concerns about having, the entry coming basically into the kitchen? I know how clean I keep my space and in a small space like this, any sort of clutter is going to be really prominent. So having that entry right into, a main spot for that could be fairly messy if you're having people over doing anything.
Or you could do your dishes.
I do, but still. Yeah, just curious what you thought about that. Is it like you thought about other layouts, other designs?
Yeah. So yeah, when I was looking at the floor plan, my main thing, I wanted to have like the bathroom and like all the plumbing in one area, and then like aside from the bath or from the bedroom, and then I figured the living area would be around there. And so then when I was looking at where to put the door, I initially had it more like central on that wall, but I didn't really want to like put it in the middle and then like kind of waste the space. So then I pushed it over to that side. I feel like I could have pushed it over to the other side a little bit and had like the table over, like had it beside the living area, I guess. But yeah, I just wanted it to be kind of on one side so that it didn't like take up too much room in the rest of the unit.
Yes.
Yes.
And then I think my other question, I just want to make sure on some of your mechanical plans, you talk about having your heat pump mounted on the roof. Any concerns about that? And is that the other question I just had about that roof space? Is that just an open structure to hold the panels at an appropriate angle, or is that actually conditioned space in that roof area? Yeah, absolutely.
Evan, do you want to chime in on that?
Yeah.
So you were talking about the heat pump?
Yep.
That was? So at least like in that model, like that was showing a water collection. Like the view, actually we took off like the side paneling just so you could kind of see in there. So it isn't actually like a fully insulated space, but it is because we didn't want to penetrate into the shipping container. And so that, well, at least we didn't want to too much. So that is meant to just be essentially like a rainwater collection to provide drinking water.
Okay.
And then I believe the heat pump would be mounted up there as well.
Okay. Now that makes sense. And I think in creating a small portable space, like if it needs to be moved. And I had a question also about your site. Was it just available space or just a space? Or?
So that was when we first started the project, it looked a lot different. We were going to have a design partner that is doing like they're making like a homeless sheltering community in this space in Victoria. And so we were going to work with them. But eventually that didn't really pan out. So using shipping containers. That's where we got. Yeah.
Gotcha.
And so that's where we started. But then.
The questions time.
All right.
You can wrap up that final thought.
Okay. Yeah. Anyway, so that's where it started, and then we decided to like just kind of do our own shipping container, and then we just kind of had that site. Okay. So we didn't.
Yeah. Because there is so much generation from the panels and parts of it made.
And there's 3 electrical engineers. I was
Yeah,
like,
there's a
3
couple
electrical
of-
engineers.
I really,
Thank you so much.
I really commend you guys for doing this as extracurricular activity.
Yeah.
Just say it. That's awesome.
Next year's
Amazing.
gonna be even better.
Yeah.
Exactly.
I hope you have fun.
Yeah, we did.
Yeah,
Great learning
absolutely.
experience.
Thank you.
Well, that's yeah.
Yeah, thank you. Good job. Good
I
job.
wanted to ask if, what if it didn't rain, but it is British Columbia?
Yeah.
So our next team is a virtual team, and that is the University of Central Florida. University of Central Florida, if you're on the line, go ahead and take yourselves off mute, turn on your cameras so we can see you.
Hey, good afternoon.
Mhm.
So this is, we'll be back.
Where's my notes on university?
Hi, good afternoon.
Afternoon.
Hello. It's fun to have some more virtual people on here.
Yes.
So, yeah, I remember a year ago, 2 years ago, doing it all virtual. That was,
Last year. Last year. Terrible.
yeah,
Yeah.
that was a lot.
Is there someone on your team who would like to take control of the slides?
I can.
That's Connor. Do you want
Yes.
to send a request? Otherwise, I can assign it to you. Maybe we'll have better luck if you request it because we had issues with that this morning.
Sure. Do you know how to do that? I'm sorry.
Let's try to just assign it to you. I just sent you a request. Did you get?
No, I don't think I did. We can just say next slide if that's all right with you, or would you rather?
Sure, no, I can do
okay.
that for you. I also just tried giving control to Stephen Ostad if he wants to try it, but I'm happy to take control for y'all as well.
Yeah, I haven't gotten a request. I'm sorry.
It's weird. That's okay. I'll plan to control the slides for you.
Okay, that'll work fine.
And I see we have Josh, Connor, and Stephen. Is there somebody else that we should have pinned up here?
Nope, that's all of us for today.
Okay, perfect. We'll get you started here in just a minute.
Great, thanks.
I can't get on the site. What's going on? Get kicked out.
I sometimes have to shut down Google.
Okay.
These are the only people that need to be hosting the computer.
Clear.
Well, I'm not on this. I'm just trying to get into the portal again so I can look at what I did. I'm just talking about the portal. We'll try it again. I'll try and Google. Okay, that worked. Google worked. I would have liked popcorn, but you're just fine. I just was seeing who else was in the room.
No, I've seen those states, Michigan, and Wisconsin up north. They probably get a lower first score because they're so cold.
Yeah, that was one of the issues with Ecotrip for a while. And version 4 has changed a little bit, but they took some old research data from the Florida Energy Center. And that basically said they did some modeling that said, okay, HSPF is seasonal, but based on some very specific factors, we should derate or prorate these based on where the actual placement is going to be. And they kind of went through what that would actually look like. So it's frustrating to me because I'm like, you're adjusting modeling based on other modeling. And it just didn't always make sense. And so it's something that ResNet is actually addressing now. It'll be
okay.
Slow.
Team UCF, we're going to kick y'all off right now.
Probably 60%.
I do want to make sure, are y'all able to see the jurors screen? Because that's how you will be getting your time warnings. You see,
Yes.
Jack, do you have those signs over there? Do you want to flash one? So that'll be your 5 minute, then you'll get a 2 minute, and then the time's up, you'll hear the buzzer, okay?
Okay.
All right. If y'all ready to begin, then go ahead and take it away. This is UCF, the Leaf Night residents.
Thank you. Welcome to the Leaf Night residence, our design submission for the Solar Decathlon 2022 Design Challenge. Next slide, please. Our team, the UCF Midnights, consists of 5 senior undergraduate mechanical engineering students shown here. Next slide, please.
With a population of approximately 24,000 people, Leesburg, Florida will be the Leaf Nights residents' hometown. Leesburg is well connected to 2 of Florida's bustling hotspots in Orlando and Tampa, and has a charming set of attractions itself, such as Venetian Gardens and the annual Food and Wine Festival. The home will sit by a brook that empties into the nearby Lake Eustis, granting the occupants a quiet and private reprieve from the surrounding lively centers of social activity. Next slide, please. Leesburg is located within Florida's Lake County, placing it in climate zone 2A, which is characterized by a hot and humid climate. Florida is one of the best examples of climate zone 2A, as it features long summers and short and mild winters. Temperatures range from 48 to 70 degrees during the coldest months, and from 75 to 92 during the hottest months. Florida is also known as the Sunshine State, which is reflected in the large number of daylight hours throughout the year. Next slide, please. A small family that likes subtropical nature, but still loves suburbia's modern conveniences was the primary kind of consumer this home was designed for. Ideally, the income earners would have a high education career with an income that can provide safely to finance the home. They would be seeking a home that soundly protects them from the Florida's continuous onslaught of sun and storms throughout their lives, reducing the operating costs to maximize day to comfort is also a big plus to the perceived consumer. Next slide, please.
While no specific architectural style was chosen, the Leaf Night residence was designed with the idea that it would appear hard on the outside, soft on the inside, and strong throughout the structure to make the consumer feel safe and comfortable. The floor plan seeks to maximize light and minimize heat, with the garage planted in the north of the building to minimize sun exposure for an unconditioned area. The bedrooms are on the east and west sides of the building to watch the sunrise and the sunset, and the south is filled with windows to let light illuminate the common areas, easing heating loads in the winter. Next slide, please. Can you go back one, please? Thank you. The hot and humid climate of Central Florida can often lead to reduced efficiencies in the home's mechanical systems. To remedy this, we use systems that worked with instead of against the climate. To create a comfortable environment within the home, a variable speed heat pump unit was chosen for the home's HVAC system. These units are ideal for climates like that of Central Florida, as they feature exceptional humidity control and energy efficiency by running at a reduced speed for a longer period of time. In addition to this, mindful placement of the compressor can further improve energy efficiency. We accomplished this by positioning the unit where it would be shaded during the hottest parts of the day. For the home's water heater, we chose to use a hybrid heat pump model due to its synergy with Central Florida's humid climate. The pump pulls heat and humidity out of the surrounding air in order to efficiently heat the home's water. We also incorporated wet walls and low flow rate fixtures in the design to further optimize the home's water usage. Next slide, please. In regards to durability and resistance, we prioritize materials that could resist high wind speeds and prevent water intrusion, as Florida is infamous for its vulnerability to hurricanes. For the walls, we chose to use insulating concrete forms, or ICFs. These structures are extremely durable, being able to withstand wind speeds of up to 400 miles per hour. Their concrete, steel, and polystyrene composition deteriorates minimally over time, resulting in ICFs possessing a lifespan of more than 100 years. For the roof, we chose to use an aluminum standing seam design, combined with a zinc coating to prevent corrosion. An aluminum standing seam roof possesses nearly double the lifespan of a standard asphalt shingled roof and is also more resistant to high wind speeds. For the home's flooring, sturdy and water-resistant materials were sought out. This led to the selection of porcelain tile for the flooring of the bathrooms and kitchen, and bamboo for the flooring of shared spaces. Next slide, please. The environmental drawbacks in regard to material selection are primarily in the production and disassembly stages of the home's life. The durability and resilience of concrete, glass, and porcelain are properties that are only achieved through energy-intensive processes. Bamboo and sheep's wool must be shipped from overseas. Polystyrene does not recycle easily, as it is bulky and does not naturally decompose. All of these drawbacks were accepted because the materials are either easily replenishable or possess extensive lifespans. With ICF walls being so durable, the Leaf Night residence can last into the next century before the walls may have to go. The thick polystyrene outer layer of the walls, triple pane vent windows, and the lofty sheep wool bats underneath the floors should create a tight thermal barrier to ease the conditioning burdens of the HVAC system. Next slide, please. One of the goals of this home was to deliver premium comfort as efficiently as possible. Passive systems, such as the Google Nest Smart Thermostat, improve the occupant experience by creating a more comfortable environment within the home. By viewing the home as a whole, we were able to make strategic decisions that would improve the occupant's living experience. We started by selecting a lot with southern exposure, which provided the home with the ideal orientation for roof-mounted solar panels. The back of the home features a hexagonal shape with a vaulted ceiling, which accentuates natural lighting throughout the day and provides opportunities for cross ventilation and for hot air to rise via the stack effect. Next slide, please.
Thanks, Connor. Hey everyone, I'll be going over the comfort and environmental quality of our home, in which we took extra measures to cater to. For our HVAC system, we chose a system that can work in conjunction with a Google Nest thermostat, as well as HEPA air filtration. Additionally, our 50-gallon hybrid water heater includes 3 different modes to satisfy the occupant's needs. The ventilation of our home features an energy recovery ventilator, a dehumidifier, and many operable windows that allow for cross ventilation when opened, like Connor mentioned. Lastly, to further reduce the noise in our home, we chose to incorporate sound deadening materials into the interior walls and floors, helping maintain an even quieter living space. Next slide, please.
As you see pictured, our HERS score is a 42 without and -4 with our renewable solar system up and running. Our system consists of 25 panels, with each panel being 370 watts. The grid can produce a yearly output of around 12,660 kilowatts, which more than covers our household yearly needs, as well as accomplishes our goal of contributing to the power grid. Next slide, please. With rising housing costs in Central Florida of around 30%, along with inflation, we realized obtaining costs and pricing for not only our property, but materials were going to be an important and vital step in our project. So as to alleviate this, we wanted to capture as much intrinsic value as we could within our build. As you can see, our build cost is $380,000 all included, well within the other range of comparable properties in the immediate Leesburg area. Our solar panel system will pay for itself within 11.5 years and continue to cover the cost for the next 15. In total, our monthly cost for our target consumer is well within their expected budget, accomplishing our goal. Thank you. Next slide.
Woo, right on time. Just made it.
Yeah. Nice.
We'll have now 15 minutes for Q&A beginning now, and go ahead and let Juris take it away.
Yeah, I had a few questions about your HVAC system. Could we go back to that slide that showed your, it's like the second or third slide. Can you walk me through sizing of it and location and your thoughts on implementing this? Yep.
Sure. So we chose a 5-ton system as our home is 2,170 square feet. We also went with a 20 SEER unit for better efficiency. We did seek to place the condenser on the east side of the building, but that was too far away from the air handler. So we put it on the west side, which is not as ideal, but we were going to either put either a tree or a small wall to try to shade that unit and make sure it's operating it with peak efficiency.
Okay. And I just wanted to make sure, I can't quite tell from your plan set. Is that air handler out in the garage?
Yes, it is.
Okay.
Well, no, sorry, it's a small closet. I think that was a last minute change to our design on Revit.
Okay. No, yeah, I just couldn't couldn't quite tell. Yeah, having anything in the garage like that, definitely going to be a big no-no for any sort of program compliance, but
Right.
no
Yeah, we
deal.
found that out at the very end and we were like, oh, need to make this change.
Yeah, I think the one thing I would say, if you've got that heat pump water heater, that should probably be in its own separate space. And putting it in the garage in your climate is actually a great idea. It's going to take the hot air and provide some dehumidification and some cooling for the space, but trying to put it in that closet with the air handler means you're going to end up with a really cold closet and a really underperforming heat pump water heater. So, just thinking that through, I do think that, yeah, based on your layout, having a good sealed closet is an opportunity for that, but maybe looking for a different location for your air handler might be a good choice.
Right. Yeah. The original idea was for the hot water heater to be in the garage, but having to put that closet in there as a last minute change, it messed that up a little bit. So yeah, that's definitely room for improvement there.
My other question is, talk me through your thoughts on the layout and design, putting that kind of octagon shape in there. What led that, and what was your goal with the design there?
So the hexagon we placed in there, it had a few design choices. Firstly, it was just for uniqueness. Not many houses have a hexagon, but that was probably one of the least important decisions we made towards that. One of the bigger ones was the stack effect, so that heat would rise out of the home. Another one was we could have a lot of windows, so that sun could enter the home, whether it was sunrise or sunset. As you can see, we have some windows that are facing the east, some windows that are facing the south, and some windows that are facing the west, or rather the southeast and the southwest. And that allows for light to enter the home.
We also wanted to incorporate the Florida room, and this is our rendition of a Florida room with the south facing direction is directly to the lake that would be out in front of us. So we wanted to encapsulate that as well for the home buyer.
I had a couple questions about windows. So can you talk to me a little bit about the types of windows you chose?
Sure. I wish we had more time to present. I would have gone over that like we did in semifinals. We were using triple paned windows with a casement style opening and composite window frames.
And the casement, I'm not as familiar with, but it's because you talk about how the walls withstand high winds. Did you make the window choice because of that? And then how are they integrated into those walls?
Sure. So the windows, could you repeat your question again? I'm sorry.
So you said it's a casement window. So does it improve the wind resistance? A casement window? I just don't know.
It's more of a thermal boundary thing. It's not necessarily the durability, but there are impact resistant triple paned windows that you can get that we were looking into.
Okay.
Did you do the analysis of in Florida? I would think double pane would be sufficient. What's the benefit of going to triple pane?
I think we were.
So it was strictly thermal was our decision. We also realized that not every window had to be triple, because as you mentioned, that's kind of overkill in certain areas. So we also wanted to incorporate the double pane windows in, let's say, like the east, west, and the north side of the building, just as a cost saver. That would be a pretty good idea.
And for passive house, what you talk about, they want low window to wall ratios. And it seems like the back of that house has a whole bunch of windows. Is there a way to optimize that differently?
Yeah, we could definitely cut down on the amount of windows we feature. But that was our attempt at maximizing the lighting of the home and not having to use artificial lighting.
I think sometimes when you have a lot of southern windows, you get a lot of glare actually. So for daylighting, fewer windows and also more lighting on the windows on the north can really help that if you do a daylight analysis.
Okay, thank you.
Yeah, did you think about including an lanai? I know that's like kind of the key Florida desired space, right? And how, if you did that, where would you put it so that it kind of could help reduce your energy consumption?
Could you repeat what exactly was it that we would include? I didn't hear.
A lanai, so a screened room with a roof, like an outdoor living space. So it would provide a little more shading.
I think
we actually wanted to incorporate that towards the rear. We didn't think of it as mostly a energy saving space if we were going to include that, because in Florida, I don't really think there's a way to get out of the heat if it's not enclosed completely, thermally, I should say. But we ran out of time to add a porch, I guess you could say.
Yeah, you mentioned that you'll get solar gain in winter through the windows, but you're also going to get solar gain in summer through those windows. So you have to manage that heat gain. A lanai could provide you shading. You could still have the windows, but it would provide some shading for those. It wouldn't provide any help in winter, of course, but it could improve energy performance in the summer.
Thank you. Yeah, we'll definitely take that into account.
Did you do any climate modeling? Like, this is so close to the lake. Where are you going to be in 50 years?
So I looked at flood risks, and it said there was a mild risk every 30 years or so. Or roughly every time a severe hurricane comes in. And one of the perks of insulating concrete form walls is they're very good against water intrusion. A lot of our materials actually are. So ideally, the home would be able to resist a flood like that, or at least with minor damage. As for in 50 years, I'm not sure exactly if the lake will rise. Ideally, that's what we're designing this house so that we don't have to get to that point with the climate. So
also the lake that it sits on is part of a larger chain of lakes, and then backs up to a place called the Green Swamp, which is where all the excess water usually drains to. And that is much more southern in relation to the house. We would be at the northern part of the chain of lakes, Lake Eustis being the very top. That's why there's such a low risk of flooding where we are.
So flooding's a big deal, but I'm sure you're also going to get a lot of, wind-driven rain events. Have you thought through water management on those windows, especially south-facing there? What's your plan for making sure you're not going to get any sort of leaks around there?
I believe it's primarily the casement style. They just form a very tight seal, and then the window frames. We didn't necessarily do any design aspects, but I assume we're all mechanical engineers, so the architecture design was very new to us. Now that you mention it, we probably could have incorporated some sort of drainage feature, like a gutter or some sort like that.
I'm kind of a policy geek, and I love the fact that you were saying the minimum home size there has to be 2,100 square feet, which
yes,
seems like you need to get involved in policy to change that. And then that all solar, if you have solar, you have to be connected to the grid. So what do you think the logic is behind large houses and controlling grid, I guess?
So the square footage of the house is a code of the neighborhood, a specific neighborhood, I believe. And the the code for the grid connection is for the city of Leesburg. So they're not necessarily connected, but if there was to be a connection, it would be, they're trying to have people sell energy back to the energy company, I believe. And that's something we considered, and it's not as much of a credit to the homeowner's energy bill as we would hope it would, but it's still beneficial. Stephen, did you have anything added?
In Florida, there's a maximum that we can contribute back to the Florida, power grid. It's 120%, and we are within FP&L's network. If you're familiar with that company, and they pay around, I think it was 11 cents per kilowatt hour. And there's actually a max minimum amount of a bill you have to pay that was just instituted, and it was $30. So no matter what, you have to pay $30 just to maintain the connection to the grid in Florida.
Are you in the part that has the feed-in tariff?
What was that?
In northern Florida, they have a feed-in tariff. It's very unique. Is that your area?
No, we're just north of Central Florida. I believe we're 45 minutes from downtown Orlando, actually.
We got just under 2 minutes left for questions. If there are any other questions from the jurors?
Yeah, I think, there's a lot of things happening in this project that I think in another location, I would say I would have lots more questions about, like the high embodied energy in foam and concrete and things like that. But I think it really, I know this part of Florida pretty well. And I think that you're really elevating the quality of the construction in this area significantly. I mean, it's like single pane windows and no insulation in a lot of cases. So I think that's really good to see. And I think just thinking more about, like, should we be building in these areas? I know, like, swamps are disappearing and homes are going up as kind of Orlando expand, like Tampa and Orlando fill in. I think is a really good question. I like that you chose a site that's kind of a vacant site in an existing development rather than kind of more what we call a greenfield site. And I think one of the things you can think about is how can you make it even more resilient? So I like that you use ICF, but do you even really need bamboo floors or porcelain tiles? Because you just have the concrete that would dry out more. Then you're not adding additional embodied carbon to the project, even though you have kind of the need from a like hurricane standpoint for the ICF concrete walls. So yeah, just kind of thinking like more about the resilience. I think you've done a lot of that, and that's exciting to see. And that's where I encourage you to think more about this.
Yeah, just to bolt on to that, in hurricanes, the biggest failures are roofs and garage doors. So making sure that, as you, and of course you said you're a bunch of mechanical engineering students, but as you think through resiliency of structures, how you connect how you make those connections and the choices you make for those two areas is as important as the wall.
We also took that in consideration when we were picking the lot. The north-south facing, typically hurricanes in Florida, if you're familiar with it, come east-west traditionally. Not always, but traditionally. So that's why we wanted the windows, if they were going to face anywhere, they were going to face south or north, primarily.
Nice job.
Yeah,
really nice job.
Thank you.
Thank you.
Thank you.
Okay, thanks again to the University of Central Florida. Next up, we have University of Technology, Sidney. Do we have any representatives from University of Technology, Sidney in the room? If so, please turn on your cameras and come off of mute so we can hear you.
Hi, can you hear us?
Yes. Yes.
Can you hear us?
Yep.
Yes, we can.
Yep.
Is it just you two that'll be joining us today?
We have 4 of us here. There's 4 of us.
Oh, awesome. Hello.
We're all
All right.
squishing in.
Good morning or good evening in Sydney, whatever it is over there.
7 a.m. on a Sunday morning.
Good morning.
Thank you for joining us.
Thank you for joining. Yes.
Beautiful.
I love.
Yeah.
The shutters. That is so cool.
So I'm going to go ahead and try to give y'all control of the slides, or would you rather me advance for you?
I think we would rather be in control if that's all right.
Okay, let me see if I can give that to Erin.
Thank you. Yeah. Annie, would you mind?
Yeah.
Like just pressing that every time we need to change. Yeah, I don't know if it'll be able to reach. Maybe Tom, can you control this thing? Yeah, sure. Yeah, I guess up to you. So basically just when it's a new thing, it'll change.
For some reason, I'm not able to give you slide control, Erin. If you can try to request it from us, we can try that.
That's all right. That's all right. Do you know how to? I'm not sure if I know how to request. It's all right. You can control for us. That's not an issue.
Okay, just go ahead and let me know when to advance the slides and I'll plan on doing that for you.
Okay, thank you so much. Do you mind if we go back to our first slide to start on? Is that all right? Thank you.
Perfect. Okay, we will go ahead and get you started here in just 1 minute.
Thank you.
Spelling somebody's snacks.
Strawberries?
I'm spelling whatever the food for the networking event is.
Yeah, I think that's down below though.
Yeah.
Yeah. Okay, Decathlons, are y'all ready? Just a
Sure.
reminder,
No.
you have 8 minutes to present, followed up by 15 minutes of Q&A. So your 8 minutes begins now.
Good morning. We're Annie, Erin, Jordan, and Tom, 4 of the 9 Decathlons from Sydney, Australia. Next slide. In the summer of 2020, Australia experienced what is now known as Black Summer. We witnessed 18 million hectares of land and over 5,900 homes be destroyed. Today, unaffordable housing markets in our cities and the recent COVID-19 pandemic have contributed to the mass relocation of Australians to the regions. Next slide. The selected site sits within a high-risk bushfire zone on the south coast of New South Wales, requiring by New South Wales Bushfire Attack Level Code specific design strategies to compensate for this. The project is situated on a north-facing slope adjacent to the Murray River, providing optimal solar access, prevailing onshore winds, and panoramic views. The location's remote nature means that our project has to be as independent and self-sufficient as possible. The local climate is Australian Zone 6, classified as mild temperate. The climatic condition, combined with excellent exposure to natural sunlight and wind, makes the site ideal for passive heating and cooling and local generated energy. Next slide, please. Energy, bushfire, and passive heating and cooling independence are critical features. We define independent living to mean off the grid, but to also mean the occupants can control their own environment. 2 residential pavilions are set into the landscape, making minimal disturbance to the land and nature. The pavilions are divided by 2 retention ponds and a connection bridge covered by a green roof. The volumes can be built at once or staged over time to make the house more affordable upfront. The house can close up completely in the event of a bushfire. The north facade is the only exposed side of the design, with triple glazed windows that can be sealed using an operable manual folding system made of FC sheeting. This wraparound veranda is an Australian vernacular feature that allows users to completely open the house and enjoy the place around them. Next slide, please.
The long section shows the open plan in living space, which is a typical of Australian homes, but also affords the greatest flexibility to occupants. The steel frame structure is organised on a 1200 by 2400 millimetre grid, the standard size of all sheeting in Australia. We can therefore make use of prefabricated, mass-produced products and reduce material waste. Next slide, please.
The material selection was based primarily on fire resistance, thermal performance, local proximity, and low carbon properties. The exterior is an elegant collage of rammed earth, green coloured corrugated steel and glass, while the interiors include warm plywood ceilings, blue and green tiles, and wooden details. Next slide. Our approach to materiality was to source recycled and locally sourced materials within a 60-minute radius in order to reduce the project's embodied carbon footprint. We selected rammed earth as a key material for its highly insulative properties, low carbon footprint and fire resistance, sourced from the excavated material on site and combined with clay deposits from the Murray River. Spotted gum window frames, a fire-resistant grade timber, are recycled from the nearby Bega timber yard, while all corrugated steel is also recycled from Bega scrap metal recyclers. Slabs and piles are produced from low-carbon reinforced concrete developed by UTS Engineering. All interior materials are free from toxins and chemicals, including non-VOC finishes, carpet and furniture to ensure occupant health and safety, while all appliances are electric, optimizing solar capacity and reducing bushfire hazard.
Next slide, please. Our approach to integrated systems and engineering was to employ passive house design techniques to thermally regulate the residence. The building envelope is designed to help insulate and trap heat loads when the operable windows are closed. Earth-coupled slabs reduce heat dissipation in cooler months and capitalize on earth cooling strategies in summer. Operable metal and glass louvers are included to above the 2400 millimetre datum line on the north and south envelopes, with smaller operable windows on those parallel, assisting in stack effect and cross ventilation. The section features 2 skillion roof forms that collect yearly rainfall, draining and filtering it through a native fire-responsive green roof and into retention ponds below. This grey water is then reused for toilets, gardening, and stored for a future event of a bushfire. This retention pond improves the evaporative cooling properties of the design during summer. The roof on the north-facing volume opens to the sun for maximum passive solar gain, while the roof on the back volume to the north opens to the north to allow for optimal placement of PV panels. Next slide, please. In order to reduce cost, our construction principles focus on simple methods and minimal finishes. Outer envelope walls are designed as sandwich panels containing a layer of rigid insulation made from recycled plastic and fastened together with non-thermally conducting fasteners to reduce thermal bridging. The roof eaves and awning overhangs have been designed to protect the northern glazing from the direct summer heat while enabling the winter sun and heat to flood the interior spaces for optimal passive heating. Next slide, please. The spaces are designed to provide maximal function within a minimal footprint. The house uses human-controlled passive systems, allowing occupants to have control over every aspect of indoor comfort, temperature, amount of fresh air and natural light, and degree of openness to the surrounding environment. The ability to control the interior environment, coupled with the tremendous access to natural light and air, will enhance the occupants' health and well-being overall. Next slide, please.
You'll have 2 minutes.
Energy performance has been assessed using NAITHS to find the energy performance targets without the inclusion of energy systems. Our NAITHS star rating of 8.8 proves that the design techniques implemented make it unnecessary for other active heating and cooling systems to be used for a comfortable living space for the majority of the year. Strategies used to reduce the overall heating and cooling loads included using high amounts of insulation where appropriate, also the use of low U values and varying SHGC values that is consistent with triple glazing provided great overall thermal performance for the building. To contextualize the performance of the building in its proposed environment, next slide please, we analysed the model in Cove tool and benchmarked the design against the ASHRAE Residential 2018 Energy Code. The building is powered by 90 square metres of multicrystalline silicon panels tilted at 12.5 degrees north to bolster the EUI offset of the unit. Moreover, the house maximizes natural ventilation, achieving a people outdoor area rate of 12.5 litres per second per person, exceeding Passive House and Green Star standards by 50%. From a functional standpoint, daylight and occupancy sensors understand when power usage can be reduced to minimize yearly CO2 emissions and associated costs. According to the selected product specifications, the wattage required for appliance use in our house during unoccupied hours is 0.45 watts per meter squared to power the fridge and heat pump hot water system. When occupied, assuming half the house is lit at any one time, we end up with an appliance use figure of 5.54 watts per meter squared. Our analysis found the building performed exceptionally well in being a comfortable Australian living environment, yielding an energy use intensity rating of negative 6.81 kilowatt hours per meter squared per year.
Next slide, please. So Sydney's median house price is 1.3 million Australian dollars, while on the south coast, it's 830,000 Australian dollars for a 3-bedroom house. It's possible to purchase a block of land on the south coast for approximately 200,000 Australian dollars. Combined with our project construction costs of 150,000, this would make the total cost 350,000. This makes our project highly affordable, as one of our design goals is housing affordability, and it's a big challenge that's facing us in Australia today. Next slide. Thank you for letting us walk you through our project.
Thank you. Let's have a round of applause for Team Australia. Okay, we will now open it up to 15 minutes of questions from the jurors, beginning now.
Can I buy this house?
Yeah.
We can sort something out.
Yeah.
So you have no mechanical system and a really beautiful architecture, and your level of detail for the integrated design is all the way down to the tea kettle. I mean, that's just a lot of thought and wonderful work. So thank you very much for this project.
Thank you.
Thank you.
I guess my only question is, will the ventilation system be able to withstand one of your wildfires? I guess I've never been in one, so I don't know how bad these are.
I mean, in the event of a fire, the house is designed to, accommodate for that. So the panels that fold up protect the house to the best of their ability. But based on the site itself, there's not too much that can be burnt around the house. It's just in that bushfire prone area. If it were to be placed in a more exposed exposed area where there's more trees and it's more likely to catch, then more provisions could be made for bushfire prevention strategies such as sprinkler systems and gutter guards and more other stuff along those lines. So in the event of the fire, we do believe that it would be successful in withstanding something like that to a very significant degree. But any damage is easily replaceable, shown by the low cost materials and the simple structure that we've incorporated.
And just sort of tacking on to Tom's answer, we sort of designed in line with the bushfire attack level housing code. So ours is in a BAL FC zone, which is sort of the highest level that you can be. So, all gaps when the house is fully closed in the event of a bushfire are no bigger than 2 mils. We've have no gutters on our house, which is sort of the most critical point where leaves can gather and then embers can catch on to that really quickly. And that's where the house can catch on fire. We've used non-combustible materials. So I think, we would be quite successful if a bushfire was to come through, that the house would survive.
I think there's this middle ground too, though, of if it's not like the house is on fire, or it's not. I think like there could be fires around. And so I think putting in heat recovery ventilation could be really smart. We saw in a lot of the fires this past year that passive houses that were really well they were very airtight, could still be livable even when their neighbors were not, because they had that ventilation going. So that's something I'd suggest for those middle times. It's hard to get, like, I'm glad we can get this nitpicky because everything is beautiful. Your video made me cry. Like, I just really about this project. So that's one thing to think about. Oh, and then I had a question too. If you're showing that you do have a small heating and cooling load with your software, where are you then meeting that from? Are you saying that you're meeting that through solar like passive solar, or where's it coming from?
Sorry, could you please repeat that?
Yeah, so you did show that you have a small heating and cooling load, like it's, so, but you don't have a mechanical system. So how are you meeting that heating and cooling load?
Sure. So the earth coupled slab, or I'll backtrack a little bit. The site is located, as we mentioned, in a climate 6 zone in Australia, which has more of a requirement for heat retention as opposed to heat gain. So the strategies that we used look to accommodate for that, such as the earth coupled slab, which, you know, doesn't allow for heat to escape as easily. But then we've incorporated systems such as the louvers and big glaze, triple glazing, high insulation that allow heat to escape in the event that it needs to, but then also it's easily retained in the for the rest of the year. So that's kind of how it remains. It keeps its thermal autonomy for the majority of the year. And yeah, did you want me to add on that at all?
Yeah, I guess maybe somebody in the room can help me with this question too, but on page 31 of your narrative, you have the graph of heating and cooling load. And so for software that I use, if it's saying I have a heating or cooling load, that means like with the current design, that's something I need to provide through a mechanical system. So it's saying, like, to me, that's saying that it needs mechanical heating or cooling, just like a very small amount, but still something.
I was going to say, I think you gave temperature range and it actually gets hot. And so I'm very interested in how cool it could get, because a lot of people's temperature range is very narrow. So I'm just curious, how do you get, if it's 100 degrees outside, or if it's hot outside, how cool can it stay inside? Because you're going to have a heating load there.
Great question. And I don't know the exact answer to the degree.
Well, I think because we're in a very mild climate, like temperament, like in the medium for summer temperature is 20 degrees Celsius, which, I mean, optimal human comfort is from 20 to 24 degrees Celsius. So, I mean, I don't think we would have extreme weather conditions that often. So in the event of an extreme weather condition, we have compensated for that with extra over eaves, awnings that can fold up, that allowed the house to become more comfortable in those times.
Yeah, I think what you're saying is, if it's not going to be uncomfortable very often. Yeah.
Yeah, like I think on a rare day it will be uncomfortable, but I think as in an Australian culture, we're also like happy to be outside all the time and have to deal with uncomfortable weather. And that's just part of, our culture and what we've grown up with as well. So
I think for this site specifically, I grew up in the area and on a property just around the corner in a house with similar materials. So it was primarily mud bricks, and we never needed a heating system. It just stayed. Yeah.
So just a couple comments. I love the name of your team, by the way. I think that's just really fun, super fun. And that decking that turns into shutters is just so cool that it's actually something I think we could implement here in the US and fire areas, because it's just what a great idea, multi-purpose. I just was really impressed with that design feature.
Thank you.
Yeah, so I guess I have one question. This is definitely for a rural area. If you were to look to more suburban area that might be on the edge of this kind of wildland interface. So for an example, here in Colorado, we just experienced, I guess, almost a year ago, the Marshall Fire. So that was in a very suburban area. We had, about 1,000 acres burned and almost 18,000 homes destroyed in just a very small space. How do you think this would work, or could this type of style be transferred to a more suburban area, or do you think it would be, or what changes would you have wanted to made if it was in a more suburban area?
Well, I think firstly, we specifically designed for this regional context, primarily because of these issues that Australia is suffering from, which is the extreme housing prices in the cities. People are wanting to move to the regions. And yeah, I think that was a lot of our strategies kind of compensating for this regional context and this primarily bushfire prone landscape. But if it was to be like a suburban environment, I think there'd be a lot of opportunities to make the design maybe more modular and like on a larger scale, maybe share energy and share kind of systems. And you'd have to reconsider, I guess, solar access and, you know, natural ventilation plays a massive role in our project, and maybe in more suburban contexts that would be affected. But I think you'd be able to think at a different scale, a larger scale, how multiple projects could operate together in a successful way rather than just a single pavilion project in a regional or rural landscape.
And I think just to add on to what Jordan was saying, that I think if we were to transfer it to a suburban context, our same principles would still work in that context. So the use of simple materials that are easily accessible and, have longevity, like
they froze.
Like they're all key principles that can be transferred into any sort of context, and it will just be parts of the architecture and the engineering systems that will need to be adapted and modulated to suit that new context.
No, great answer.
Yeah. What's a Gabion wall? Did I say it right?
A Gabion wall is basically, you would probably see it in more like medieval times in a sense, in like the UK, but they're basically a wall that is a metal, it's generally aluminium cage that is then infilled with sort of rock aggregate and anything else like that. So for example, on our site, there's a random concrete slab there that we would need to demolish, and then we could use the aggregates from the concrete and infill the wall with that. And they're really good use. So we've used them on sort of the sub level of our house because we're on a hill and we've elevated our house a little bit. So they sort of form the sub walls for us, the subfloor walls. And they're really good because you don't need to have a drainage cell around them. They're self-draining. The rocks, if they got wet, would retain water. So in the event of a bushfire, they would also help to sort of slow it down if it was to come close to the house. They have many advantages to them.
I think the Solar Decathlon should take your district's motto of clean energy to eternity as their motto. That's a great one. Thanks for sharing that. The one thing I'm not following is your financial economics on a $350,000 house for 30 years for if the payment's only $1,080, that's about less than a 1% interest rate. I'm sure interest rates in Australia aren't that low, are they?
No, but I think the location, like, as I guess I'm repeating myself a little bit here, but this is a trend in Australia and on the East Coast that a lot of people are moving to these smaller communities outside of the city because of the significantly cheaper in land cost. So that is a massive kind of element of this, where you're not spending, $1.5 million Australian dollars just to buy a small terrace house in the city. You can spend 200,000 and get a large plot of land. But I think coupled onto that, the lack of, or the reduced need for energy plays a big role in cutting costs. This kind of local material palette that everything is very accessible and can be delivered to the site in a cheap fashion. We also designed every element to the standardized proportions of large Australian manufacturing. So there's less wastage. You're not designing, very specific details. This is all mass produced kind of, easily accessible material. And I think the other thing that plays into this like reduced market the reduced cost of the project is the fact that, we were excavating, which would have been one of the more expensive things, but we used all of that excavated material as our insulation. So repurposing one of the highest cost elements as insulation there, it's just like doubling up, I guess, functions of of more expensive kind of elements of the project.
And I think we also used really simple construction methods. So, I mean, sort of anyone, not anyone, but you could have sort of one contractor there and then they could help, people of the community could help put this together, or the owners of the house could help put this together. So I think that's sort of encouraging the idea of a circular economy where everyone can get involved and it's accessible. So I think that also helps to offset the costs. So instead of having to have, 10 contractors on site where each of their hourly rates are $50 to $100 per hour, you could have, half the amount and then also have the people of the house helping put it together as well is an option.
Yeah, I think you did a wonderful job on the embodied carbon and, getting local materials and a simple design that's replicable. I just think your financial calculator is a little broken. You might look at those numbers one more time.
Okay, we can have another look.
We have maybe 30 seconds if y'all want to wrap up with any comments.
I just want to thank you for being up at 7 a.m. on a Sunday. Spending your time with us.
Thank you.
Yeah. Your
Excellent
documentation has been incredible.
Yeah.
Very good
Very,
job.
very nice job.
Thank you, guys.
Thank you so much.
Let's have a round of applause for the Decathlons. Okay, with that, that is our last presentation for the day. Just a reminder, there is the networking event going on in the cafe. For those of you who are joining us virtually, you can also access that via the Remo platform, and more information on that is available on Whova. We will see y'all back here, at the Marriott tomorrow at 8 a.m. for breakfast, followed by the award ceremony. Great. Thank y'all.
Not us so much. I do smell food.